Our celestial neighbor, the planet Mars. Astronomers once considered Mars to be a long, barren, and geologically dead rock in space. But since the arrival of our probes beginning in the 1960s, the planet has come alive for us. It does not reveal the inactive and worn-down landscape astronomers and planetary scientists had expected. Nevertheless, investigators continue to apply geologic concepts based on their understanding of the Earth and the Moon. They could only see volcanism, erosion, surface movement, and surface collapse, all punctuated by episodic impacts from space over billions of years. What force created the sharply cut gouges and depressions across the surface of Mars, looking as if a giant trowel descended to scoop out material at radically different and irreconcilable depths? Running north to south, we see massive interwoven scratches or grooves extending hundreds of miles. And how remarkable that a planet only half the diameter of Earth exhibits canyons on a scale dwarfing anything seen on our own planet, and mountains that would tower over Mount Everest. Today, no planet outside the Earth has received more attention than Mars. But the mysteries and theoretical contradictions have grown spectacularly. For decades now, investigators have wondered why the two hemispheres of Mars look as if they were formed in different worlds. A southern hemisphere dominated by craters. A northern hemisphere with only sparsely scattered craters. And note the contrasting crustal depths of the two hemispheres. Shallow crust in the north, much thicker crust in the south. Why would a planet evolving in isolation display such a profound dichotomy? It's as if some unknown force excavated the northern crust miles deep. The hemispheric removal of crustal material requires a force external to Mars, acting on the planet. But when it comes to external events, scientific convention has only one thing to work with: random collisions. Could a planetoid or huge asteroid crashing into Mars have removed millions of cubic miles of crust? A shattering impact is all that theory would allow. But what would Martian history look like were we to include electrical events? Events on a scale sufficient to sculpt the surface of the red planet from pole to pole. Of all the enigmatic features in the solar system, perhaps none provokes greater amazement than Valles Marineris. The largest canyon on any planet or moon, the Deep Trench Complex stretches a third of the way around the planet. Hundreds of times larger than the Grand Canyon. It would reach from San Francisco to New York and beyond. Prior theory of planet formation had never anticipated such a chasm on a small planet. What natural force excavated this colossal trench? With the arrival of the Mariner probes, NASA scientists thought the chasm could have been cut by water erosion, though nothing even close was ever achieved by water on the known watery planet Earth. On any erosional hypothesis, 3 million cubic miles of material were removed. 3 million cubic miles, and it had to go somewhere. Neither the means of fluid drainage nor the vast outflow required are in evidence. Now we know that the Valles Marineris reaches to a greater depth than any outflow channel originally envisioned. And the tributaries imagined by some turned out to be cleanly cut alcoves and stubby depressions. They are not connected to feeder streams at all. One portion of the Valles Marineris system in particular underscores our point here. Planetary scientists acknowledge that Hebe's Canyon, much larger than our Grand Canyon, is an inseparable part of Valles Marineris. As scientists have now acknowledged, it was certainly not created by water. Nor is it plausible to suggest that surface spreading created the massive chasm of Valles Marineris, with its repeated morphology of sharply scalloped walls. The surface was not torn, it was carved, and the detailed images imply a removal of material along the entire length of the chasm, a process clearly illustrated by the neatly machined so-called tributaries all the way up to their rounded, cleanly cut terminations. Whatever formed the canyon complex did not stop at the margins of the primary channel, but added irregular craters and crater chains and surface grooves and gouges. So the question cannot be escaped. Is there anything known to science today that can account for the extraordinary profile of Valles Marineris? There is an explanation well known to science, though it's never entered the geologist's lexicon. Lightning. In the plasma laboratory, its power is demonstrated in electric discharge experiments. But the form unfamiliar to conventional science today is the cosmic thunderbolt. It was the brilliant engineer Ralph Jurgens who first suggested decades ago that a cosmic thunderbolt carved Valles Marineris. With the benefit of more recent data, electrical theorist Wallace Thornhill returned to this extraordinary possibility. Yes, the electric hypothesis will unnerve many scientists, but it is the only hypothesis that meets the test of direct observation. Here is a scar left by an electric arc on a piece of wet wood. Electric discharge provides a direct and complete explanation for the Valles Marineris. The so-called tributaries of the valley were cut by secondary streamers of the discharge. That is a typical signature of an electric arc when it cuts a surface channel. And here is the scar from electric discharge to an insulator. Notice in particular the network of secondary streamers to the left, a perfect counterpart to the western edge of Valles Marineris. It was long held that this remarkable region on Mars was the result of uplift, fracturing, and spreading. And from a distance it did look like fracturing. But with a closer view in front of us, it is simply irrational to cling to that interpretation. Material has been cleanly removed, exactly as in the discharging to the insulator. The evidence now available demands a new perspective, a larger field of view. In Thornhill's interpretation, the discharge took the form of a plasmoid, not unlike the plasmoid from which a spiral galaxy is formed. On his website, Thornhill noted how the discharge effect spiraled upward to the east and downward to the west, an effect that shows up quite clearly on the elevation map given on his website. In fact, if we extend the view of the elevation map, we see an even larger effect. It seems that the spiraling trails to the east and west nearly completed 2 circles as they swung back toward the trench itself. But one difference between the northern and the southern extension stands out. The northern extension is entirely constituted of ravines and depressions, while the southern extension consists of ridges and mountainous terrain. For this unusual contrast, electrical experiments offer a startling explanation. It was George Christoph Lichtenberg who in the 18th century first showed that electric arcs create ravine networks on more negatively charged surfaces and elevated ridges on more positively charged surfaces. Could it be that simple? That a cosmic thunderbolt carving Valles Marineris acted on 2 regions of different charge, negative to the north and positive to the south. If such was the case, the only plausible cause of the charge differential would be an electrical exchange between Mars and other charged bodies in the past. And what was the relationship of these events to the hemispheric dichotomies? The removal of crustal material to the north and the densely cratered southern hemisphere. In the electrical interpretation, the violent excavation of the surface to create Valles Marineris would have created immense deposits of sediment on surrounding topography. And indeed, we see that previous craters in the region were completely buried, with only the largest craters appearing as outlines penetrating through the deep deposits. It's apparent that the released material had a net drift to the west, since the blanket of deposited sediment stretches all the way to the eastern flank of the towering Olympus Mons. Keep in mind as well that an electric discharge at energies necessary to create the chasm of Valles Marineris would have ejected great volumes of rocky material into space. Much of the rocky debris would have fallen back to litter the Martian landscape. And indeed, shattered rock of all sizes across the surface of Mars is a long-standing mystery, and the mystery is resolved by electrical events on a continental and even hemispheric scale. Given the energies of the events, considerable volumes of material would have surely escaped the planet altogether. And what might this tell us about the Mars-Earth connection in our reconstruction of ancient events? Or the surprising discovery that rocks from Mars have fallen on our own planet. One of the great surprises of the space age was the discovery that certain meteorites had arrived from the planet Mars. Initially, most scientists rejected the idea outright. For a rock to escape Martian gravity, they could only imagine an asteroidal impact, blasting rock into space at more than 3 miles per second. That's 5 times the muzzle velocity of a hunting rifle. The energies would either pulverize or vaporize the rock. But the question was eventually settled by gases trapped inside a suspect meteorite. The gases bore the atmospheric signature of Mars. By 2003, at least 30 meteorites had been identified as Martian. But how could the removal of rock from the Martian surface have occurred? Planetary scientists began to offer exotic speculations based on mathematical models. No one seems to have wondered if the vast debris fields of Mars might point the way to discovery. Even the smaller rocks viewed here from space would weigh tons on the Earth. We have proposed that in a former epoch of planetary instability, electric discharge excavated the Martian surface miles deep, throwing massive quantities of rock into space. This would mean that most of the Martian rocks reaching Earth would have come from well below the surface and would not even bear the atmospheric signature of the planet. So it is not unreasonable to suspect that the planet Mars was not a small contributor, but the greatest contributor to meteoric bombardment of Earth in ancient times. On this question, ancient testimony holds a surprising answer. Worldwide accounts describe apocalyptic wars of the gods, punctuated by lightning and falling stone. Rocks from space falling on the Earth have no connection to lightning and thunder in our own time. But the ancient connection is clear. In many different languages, meteorites and exotic rocks were called thunderstones, or thunder eggs, said to have fallen in the great wars of the gods. It seems that the answer lies with the world's first astronomers. They insisted that rocks from space were hurled by the warring thunder god, the planet Mars. From one land to another, ancient sky worshippers celebrated the planet Mars as the cosmic prototype for the warrior on Earth. It seems that rocks encircling Mars, when Mars loomed huge in the heavens, appeared as a fiery retinue of warriors with a blazing countenance. The terrifying Maruts of Hindu literature derive from the same Indo-European root as the Latin Mars. They are the sons and companions of the Hindu Rudra, the Red One, who could hardly be other than Mars itself. The Maruts whirled in the heavens, bringing blasts of fire, of lightning, and falling stone. Babylonian astronomical traditions declare precisely the same thing of Nergal, the planet Mars. Raging demons with awesome numbers run at his right and at his left, the texts say. In the same way, the classical poet described the dwelling of the Greek Ares, the Roman Mars, ringed by 1,000 furies. Just as a horde of berserkers or the furious Valkyries accompanied the divine warriors in archaic traditions of Germany and Scandinavia. For many years, our claim has been that catastrophic electrical exchanges between Mars and other planets at close range removed immense volumes of rock, dust, and debris from the surface of the red planet. But now, planetary scientists face an additional challenge. The surface of the Martian moon, Phobos, reveals a chemistry very close to that of Mars itself. Scientists now say that Phobos is not the captured asteroid that they had once thought. Like the meteorites from Mars, even this moon appears to be composed of material blasted from the planet's surface. Theorists envision rocky debris orbiting Mars after a major impact event, then gradually accreting into the observed moon. But it's surely more likely that collisions of rocks in orbit would progressively wear them down, not create a moon. The idea of gravitational accretion followed by meteoric impact is in fact contradicted by the most visible surface features of Phobos. Imagine the secondary collision that impact theories required in order to create the gigantic Stickney crater, 5.6 miles in diameter, almost half the diameter of Phobos along the axis of the supposed impact. The trivial gravity of the moon could never hold together a loose collection of rocks experiencing such an event. Parallel channels and crater chains running in every direction. Is it a coincidence that everything required to fuse material in the implied way has already been demonstrated by electric arcs in the laboratory? Pinching material into spherical shapes. The same electric force that produces parallel channels and crater chains. It should not surprise us that a body fused electrically into a rough sphere would continue to attract the surrounding dust created by the prior catastrophic events on the Martian surface. But no popular theory has explained how Phobos acquired a surface layer of dust or fine grain estimated at 100 meters deep. Even moderate vibrations created by the larger supposed impacts would immediately have propelled collected dust grains back into space due to the rock's minuscule gravity. The available evidence points directly to the very centerpiece of ancient fears, the cosmic thunderbolt, and the ancient story of the great warrior in the heavens, of his raging companions, and of hurled stone does not end here. No surface feature on any body in the solar system is more recognizable than the great scar of Valles Marineris. And it appears that ancient nations preserved a story about this memorable scar. The scarred face of the Aztec god Xipe, the celestial model of the devoted warrior, is not easily forgotten. And many cultures recall a legendary warrior or giant recognized by his distinctive scar. But could the scarred god really have been the planet Mars? Scarface was the name of a legendary Blackfoot Indian warrior, also called Star Boy. His counterpart amongst the Pawnee was a great warrior named Morning Star, not Venus, they say, but the planet Mars. The Greek Ares personified the lightning weapon, and the Greeks named the god as Mars. When wounded in battle, he rushed to Zeus with the shout of 1,000 warriors to display the deep gash. In the different cultures, the warring god appears alternately as a hero vanquishing chaos monsters and a rogue warrior or dark power. We see the two aspects of the warrior archetype in the Hindu Indra, famed for the cosmic thunderbolt, and the giant Ravana, who is said to have been permanently scarred by the thunderbolt. Greek poets knew the monster Typhon as the owner of a lightning weapon, but also as the lightning-scarred god. And the same is true of the giant Enceladus, alternately said to have been scarred by the thunderbolt of Zeus or the spear of Athena, which meant the same thing. We have good reason to ask, therefore, if the Scarface theme derived from remembered events, when planetary gods waged battles in the sky and the planet Mars acquired its unforgettable wound. In its sheer size, the towering Martian mountain Olympus Mons dwarfs anything seen on Earth. The great mound on the Tharsis Rise stunned planetary scientists as it rose through a dust cloud to greet the Mariner 9 mission in 1972. Almost as flat as a pancake, Olympus Mons is 3 times the height of Mount Everest and as wide as the entire state of Arizona. From its discovery onward, planetary scientists interpreted Olympus Mons as a classic shield volcano, comparing it to the great shield volcanoes of the Hawaiian Islands. But Olympus Mons is as large as the entire Hawaiian Island chain of mountains, from the seafloor to their summits. Numerous features distinguish it from any shield volcano on Earth. Its steep scarp rises up to 4 miles high. No shield volcano offers a counterpart to this towering cliff. The defining feature of a shield volcano is the gentle extrusion of fluid or low-viscosity lava. Shield volcanoes do not present a scarp, and a scarp 4 miles high is simply out of the question. In fact, one enigma after another leaps out at the observer. A blanket of incredibly fine, filamentary ridges and ravines. A surrounding aureole, exhibiting sharply cut ridges and channels, and stupendous carved blocks. Subsequent to its formation, much of the aureole to the east was apparently buried by equally enigmatic activity in the region. Indeed, the Tharsis Rise as a whole is a long-standing enigma, 2,500 miles across and more than 6 miles high. A vast bulge of this sort has no place in the standard evolution of an isolated planet. Planetary scientists still debate the enigma, but if Mars formerly engaged other charged bodies at close range, the Great Bulge is the very deformation we would expect. Claimed that the surface of Mars was sculpted by electric discharge in an epoch of solar system instability and planetary violence. Yes, this is an outrageous idea, but Olympus Mons itself has all the characteristics of a lightning blister. Such raised, bell-shaped blisters can be found on the caps of lightning arresters after a cloud-to-ground strike. And we find them in other natural settings as well. They are elevated fulgurites, what some have called fulgamites. The discharge that creates a raised fulgurite is often followed by lesser strokes along the same ionized path, creating overlapping pits on the top of the formation, just like the circular craters on the summit of Olympus Mons. On the Martian mountain, the smaller craters center on the walls of the larger and are cut to greater depths, as if with a cookie cutter. The material that forms the raised fulgurite is scavenged from the surrounding surface. The result is an encircling depression or moat. This characteristic is so clear and obvious as to raise a critical question. Is there a moat around the base of Olympus Mons? Planetary scientists say there is a moat, but that its remains are only slightly visible to the west, and the rest of the moat has been buried by later deposits of material whose origin is still debated. They explain the moat as the effect of Olympus Mons sinking into the local terrain over long spans of time. But is another explanation possible? The features of Olympus Mons are, in fact, a perfect fit to an electrical interpretation, down to numerous details. Several years ago, Wal Thornhill conducted a laboratory experiment to demonstrate the effect of an electric arc on a positively charged, or anode, clay surface. At moderate power, the electric arc raised a circular mound from the surrounding material to create both a moat and an encircling fluid aureole extracted from the clay, while also carving a crater on the top of the mound and cutting pits and gouges in its flanks. As the power was increased, the arc briefly stopped moving and burnt a smaller circular crater within the pre-existing crater, leaving a glowing spot. Scaled up to an interplanetary discharge, that glowing spot represents a duration and temperature sufficient to melt the floors of the Olympus Mons caldera craters and to produce their remarkably flat surfaces. The Olympus Mons aureole also has its analog on the aureoles of lightning blisters, showing concentric scarring. This distinctive pattern directs our attention to a stunning, highly enigmatic counterpart on the Olympus Mons aureole. In conventional terms, the similarity can only be accidental. And here is an equally profound mystery. Much of the original aureole was overwritten by subsequent scarring. It's only necessary to look closely at the images to see that the overwriting was achieved by a force acting from above, with no regard for previously formed ridges and channels. That's the trademark of electric arcs acting on a surface. In an electrical interpretation of Olympus Mons, successive strokes from a cosmic lightning bolt lifted the peak and carved the craters on the summit. The Olympus Mons caldera illustrates the effect of a sputtering, rotating arc superimposing flat-bottomed craters on the summit of an anode blister. Its rapid movement will frequently cut steep terraces into the walls of the superimposed craters. We see the effect most clearly on the caldera walls of neighboring Aescurius Mons. On a planetary scale, a cylindrical rotating electric discharge can be seen as an array of smaller cylinders. A good example is the cylindrical Earth auroras, formed by curtains of smaller discharge cylinders. When electric arcs sputter across the surface, they will often stick momentarily to one spot, creating a distinctive scalloping effect. An effect evident on the caldera walls of Olympus Mons, and even more evident on the caldera walls of Hecates Tholis to the north. Cleanly cut scalloping is not apparent on the walls of shield volcano calderas. The highly filamentary blanket on the summit of Olympus Mons is to be expected if an interplanetary arc created a focal point of negative charge on a positively charged surface. Like the fine filamentary tail of a comet moving through the weak electric field of the sun. Here we would look for a similar effect on the massive cloud of dust and sediment that fell upon the region. Radial filaments, perhaps even electrically fused material, would have poured over the flanks and scarp of Olympus Mons to fill the surrounding moat as a permanent record of the movement of charge. In truth, no shield volcano on Earth replicates the morphology of Olympus Mons. Yet the pattern is repeated more than once on the Tharsis Rise of Mars. Not just superimposed craters and terracing, but as seen in the laboratory experiments with electric arcs, a spectacular array of surrounding pits and deep surface gouges. And most extraordinary is the fact that the expanse of carved surface seen here reveals not a single opening to the great voids that are supposed to lie beneath the surface. The voids into which scientists have assumed these pits and gouges collapsed. Collapse pits are typically quite obvious, revealing either their connection to local fissures or openings to cavernous space below. Examined critically, the supposed shield volcanoes of Mars do not reveal the expected features. This may not exclude the possibility of active volcanoes in the planet's violent past, but with higher resolution images, the spectrum of enigmas has broadened spectacularly. Electrical events are scalable, and it should not surprise us to find that events similar to those producing Olympus Mons occurred on a smaller scale as well. In fact, the surface of Mars is replete with small mounds surmounted by craters. Abundant cratered mounds remain mysterious to planetary scientists. Many of these mounds are remarkably similar to raised fulgurites. In many instances, we see the cratered mounds surrounded by moats or borrow pits. An electrical explanation may be the only explanation that can withstand scrutiny. Most of the formations are under half a mile in diameter. Where we see one cratered mound, we typically see others, sometimes by the hundreds, even by the thousands. We see strings of cratered mounds, and we see parallel strings, an unresolved geological enigma. But an enigma that reminds us of the parallel streamers common to electric discharge. Many of the higher resolution images are quite recent, and yes, it's too early to impose any sweeping interpretation. But the greatest mistake will be to ignore the converging lines of evidence, evidence that points to planet-wide electrical sculpting of the Martian surface not that long ago. Is it possible to identify the events that shape the surface of the planet Mars? A planet of vast but unrecognized landscapes. Vista after vista, eluding every attempt to explain them. Scientists labor to solve the mysteries through textbook theory. But if, as we have claimed, the cause was electrical, they will never get the expected answers. Many details of a new interpretation come from laboratory experiments with electric discharge. But how far can this new interpretation take us toward an understanding of Martian history? One advantage of the electrical perspective is that its every implication can be tested against massive layers of evidence now available, including wide-ranging experiments with electric arcs. If, as we've proposed, Mars was immersed in hemispheric discharge, the planet can be viewed as a laboratory in space for testing the electrical hypothesis. As seen in lightning displays, electric arcs exhibit dendritic branching, called Lichtenberg patterns. These look very much like the dendritic erosion created by flowing water. And electric arcs exploding across a surface can produce sinuous channels that also resemble fluid erosion. But there are differences. In electric discharge to a solid surface, the electron pathways frequently create dark spotting, or chains of craters, running along the channel floors or close by. The presence of crater concentrations in relation to surface channels offers a fundamental test of the electrical hypothesis. In electric experiments, we also see coronal streamers radiating perpendicularly from the primary discharge channel. Both the cratering and the coronal discharge are keys to a new understanding of the Martian surface. Did electric arcs cut the great channels on Mars? Nergal Vallis is some 3 miles or more in width and 250 miles in length. Yes, it did look like a dry riverbed when first seen by the Mariner 9 mission in 1972. But the original confidence of planetary scientists soon gave way to doubts, then to contradiction. A river can take many twists and turns along its path, but its tributaries will not look like the blunt alcoves of Nergal Vallis. Martian channels exhibit the predictable features of an electric scar. Rotating cylindrical arcs, sputtering along the primary discharge path, produced scalloping of the channel walls, with sharp angular projections that are inconsistent with fluid flow. The same process left overlapping craters and alcoves that make no sense in terms of familiar erosional patterns. We see virtually identical craters, alcoves, and sharply cut, stubby gouges along Nanitti Vallis. Numerous other Martian rills underscore the same enigma, and the unanswered questions grow year by year. Planetary scientists identify depressions such as these as collapsed lava tubes. Lava tubes form as flowing molten rock cools and hardens at its surface, insulating the lava below so it continues to flow in a tube that eventually empties. When an empty lava tube collapses, the result will be an entrance to a lava tube cave. A good example is Barker's Cave in Australia. So a cave entrance is the first thing to look for on Mars. The second thing to look for is a rubble field created by a collapsing roof. And a third thing to look for is abundant outflow, since the emptying of a lava tube requires an outflow region. but in reviewing innumerable instances of claimed lava tube collapse on Mars, we find no cave entrance, no rubble field from a collapsed roof, and no outflow. The depressions stand alone, with literally nothing to support the theoretical interpretation. Like any fluid, lava flow follows topographical relief, always running downhill. The channels seen here change direction randomly, in apparent disregard for topography. They make 90-degree turns, unrelated to surface gradients. And they also cross over each other with no disturbance of either. These depressions cannot be collapsed lava tubes, but what are they? What you see here is not the planet Mars. It is a surface affected by a very high voltage but microamp current, creating a complex of gouges and craters. Again, in electrical terms, craters and channels are inseparable companions. In responding to the mysterious channels and depressions on Mars, many planetary scientists thought they saw spreading and fracturing. And indeed, evidence of fracturing is present on Mars, as seen here. Here there are no associated craters or crater chains, and the nature of the stresses acting on the surface is an open question. Planetary scientists think in the same terms when considering the region of Avernus Collis. They identify the channels as cracks or fractures. But why the concentrations of craters and crater chains? A rotating electric arc traveling across the surface can alternately sputter forward to produce linear chains of craters, or advance on a continuous path to cut channels as if by a router, with uniform depth and parallel sides. As seen in laboratory experiments with electric discharge channels, here the channel width will be the width of the rotating arc at its contact with the surface. The question of crater formation on rocky planets and moons must be reopened. The impact explanation would mean it's only necessary to count craters in order to calculate the age of a surface. But electric discharge on a hemispheric scale could quickly create a surface that looks 1 billion years old to those counting craters. Plasma scientist Dr. C.J. Ransom of VimaSat Laboratories conducted a series of experiments with electric arcs. Electric discharge produced surface cratering patterns closely resembling those observed on planets and moons. Even the surface darkening and central bumps or mounds of so many craters on Mars were present in the laboratory experiment. Electric arcs can also produce cratering patterns that could never be produced by impact. Complex terracing of crater floors and crater walls are a common effect of a rotating electric arc or discharge streamer. Across the surface of Mars, we observe countless examples of exotic terracing. Impact theory was never able to resolve the mysteries. So-called bullseye craters, with a central crater inside a larger crater, are surprisingly common on Mars. Could this be a rare accident? That explanation is reduced to absurdity when two such craters are seen side by side. In fact, several bullseye craters appear within the same region of Mars. But an ionized discharge path of lightning does allow for subsequent discharge along the same path. The bullseye crater is a logical extension of the electric model. And when it comes to improbable events side by side, these two craters with central peaks each terminating in another crater will certainly never be explained by impact. Impacts do not create hexagonal craters. But look closely at this region of Mars, and you'll see several hexagons. An observed form taken by rotating plasma, as seen in the planet Saturn's electrified polar hexagon. In an extended discharge, systematic cratering, pitting, or etching can be the norm. That's why in industrial applications, electric discharge machining can achieve exceptionally dependable results. The microscopic pitting of electric discharge can give a consistent depth and a remarkably smooth surface, despite the fact that the surface is entirely constituted of craters or pits. The same effect can be observed on seemingly smooth surfaces in the northern hemisphere of Mars, surfaces that have been excavated miles deep. But look more closely with the help of recent high-rise images, and smooth surfaces are revealed to be nothing more than fields of small, densely packed craters. The baffling crater field seen here, like so many others on Mars, is a perfect counterpart to an electrically machined surface. Don't underestimate the scale of this dilemma for planetary scientists. We witness the pattern at both the low points and the high points on Mars. From the bottom of Zunil crater in the depressed northern hemisphere to the highest point on Mars, the summit of towering Olympus Mons. Here, no grasping for conventional explanations such as a dune field could possibly account for what leaps out at the observer. The baffling crater field seen here, like so many others on Mars, is a perfect counterpart to an electrically machined surface. More than 2 centuries after Benjamin Franklin flew his kite, the origin and behavior of lightning continues to amaze and to puzzle the lightning specialist. Lightning will occasionally imprint its distinctive form on terrestrial surfaces. and even on the skin of humans. In the laboratory, the counterpart to lightning is the Lichtenberg figure, perhaps the most common and fascinating form taken by electric discharge. Dendritic means tree-like branching, and dendritic forms can be easily confused with fracturing. The dendritic patterns seen here are not fracturing as the term is normally understood, but electrical breakdown channels on a polycarbonate plate. George Christoph Lichtenberg appears to have been the first to demonstrate the different forms taken by dust on positive and negative surfaces. A line of investigation later followed by others, but with no impact on planetary science. Late in the 19th century, industrialist Lord William G. Armstrong explored the power of electricity to produce exquisite forms on surfaces of different charge. The feathery qualities of Lichtenberg figures on a negative surface could be compared to the more dendritic patterns on a positive surface. At Stone Ridge Engineering, the technology of Lichtenberg figures has produced an art form, lightning captured in clear acrylic blocks. The blocks are bombarded by electrons from a 5 megavolt particle accelerator, arriving at nearly the speed of light, but coming to a stop within a fraction of an inch into the block, a cloud of trapped negative charge. Here, the event producing the dendritic channels is triggered by a simple stroke of a metallic pin. That is all it takes for a breakdown of the insulating material and a nearly instantaneous release of charge in dendritic channels. A millisecond lightning storm frozen into the acrylic block. The branching of the electron channels gives a spectacular fractal pattern, apparently occurring all the way down the scale to the molecular level. From what we have earlier presented, it is evident that planet-wide electric discharge created vast regions of raised Lichtenberg figures on Mars. Laboratory experiments show that in regions of positive charge, dust will typically gather into raised Lichtenberg formations, standing out from the surrounding terrain. In fact, sharply sculpted dendritic ridge systems are abundant on Mars, showing up wherever the highest energy events are implied. The Great Trench of Valles Marineris is an extraordinary example. Here we find the raised Lichtenberg figures exactly where we would expect them, running down from sharp cliffs and high points in predictable patterns stretching for hundreds of miles along the trench. Yet strangely, the mystery receives almost no mention by planetary scientists. We also observed dendritic ridges on the Great Mound of Olympus Mons, both on the miles-high scarp and on the caldera walls. In fact, the mystery is global. We see the same pattern on the walls of major rills. We see it along the so-called fractured terrain of Noctis labyrinthus. And everywhere on Mars, we see the dendritic patterns reaching down from towering cliffs and mesas. We even see such ridge systems descending from the rims of large craters, opening the door to a much broader perspective on crater formation. In the hypothesis presented here, many craters on Mars were produced by the same electrical events that created chains of craters and a great variety of channels or rills. As a discharge column sputters across the surface, its diameter will vary with discharge energy and a narrowing or pinching by the induced magnetic field. The pinching effect will be most strongly focused at the point of contact with the surface. The sputtering arc will leave a unique signature in the form of scalloped walls. Popular explanations say that surface collapse must have produced these cratered channels. But scalloping effects on Mars are by no means limited to chains of craters. Planetary scientists cannot agree on the forces that created this bizarre channel network north of Valles Marineris. Other channels that are said to have been caused by fluid flow, either water or lava, exhibit the same scalloped walls. Similar, neatly cut scallops appear on the cliffs of towering mesas. And the so-called calderas of the great mountains of Mars reveal the same pattern. Even the celebrated Victoria crater, supposedly formed by impact, exhibits alcoves and scallops similar to those of the great rills and valleys. And the scalloped walls of Zunil crater are virtually indistinguishable from the scalloped walls of Valles Marineris. Additional patterns enter the picture as well, including a consistent global connection between scallops and dendritic ridge networks. The explanation appears to lie in the fractal nature of cylindrical current sheets. Current flow can metamorphose into secondary cylinders in fractal-like substructures, to be pinched by the induced magnetic fields into a narrow, highly focused discharge. We see this interplay of different scales in the cylindrical currents of Earth's auroras as charged particles enter and exit the polar regions in an electric circuit. Invisible current sheets, magnetically pinched at Earth's poles, divide into visible curtains of secondary cylinders, all dancing in the turbulence of Earth's upper atmosphere. The same electromagnetic structure arising from charged particle movement will at times be seen in the electrified tails of comets. In the largest scale events carving the surface of Mars, we envision multiple columns of charged particles being pinched into a narrow discharge at the surface. This established principle will be crucial to comprehending the giant Valles Marineris with all of its accompanying chasms. Smaller scallops within larger scallops. They are the imprint of pinched cylindrical currents, constituted of smaller cylinders. The pattern occurs repeatedly and is surely no accident. Consider the consistent relationship between the scalloping effects and Lichtenberg ridge systems. The most prominent of these dendritic forms are those that separate the larger scallops. The smaller dendritic ridges define the boundaries between smaller scallops. At both scales, the ridge networks can be seen as the final events in catastrophic discharge activity, as charge redistribution gathered and fused loose material into the familiar Lichtenberg patterns. In this revisioning of Martian history, contradictions find a unified resolution in an electrical cause. Enigmatic craters, crater chains, dendritic ridges, scalloped craters, calderas, and rills. All are connected to the observed behavior of electric discharge. Here is an image of electric arcing to a negatively charged surface, capturing the feathery discharge glow or corona. The corona is constituted of extremely fine, hair-like filaments radiating from the primary streamers. On a surface affected by electric arcing, experiments show that regions of localized charge can attract dust or sediment into a record of the electrical activity or discharge pathways, down to many fine details. Here is a ridge complex on Mars, covering thousands of square miles. The ridge forms have puzzled planetary scientists for more than a decade now. Since standard geology does not include such forms, this unique behavior is a logical test of the electrical hypothesis. Examined closely, we see perpendicular, hair-like filaments illuminated by the sun, confirming that electric discharge attracted dust into raised relief. This exotic formation was produced electrically by D.Z. Parker on a CRT screen, showing a gathering of dust in a region of previous discharge activity. The ridge, with its fine filaments, offers a striking counterpart to the baffling Martian formations. We have suggested that the northern hemisphere of Mars was eroded electrically to a depth of 5 miles or more. as seen on the global elevation map. It is only reasonable, therefore, to look for transitional zones on the margins of the more depressed or heavily eroded regions. If the erosion was electrical, what should we expect to find? Particularly in the regions that separate the low-lying northern latitudes from the elevated and densely cratered southern hemisphere. We should expect to find what we do find. Vast regions from the equator northward, showing the predictable phases of electrical erosion. First, electric arcs raking across the surface created a network of channels, cutting the region into discrete blocks. Then the arcs, acting on the sharp edges of the blocks, continued to extend the valley floors, leaving separate angular islands. The islands, standing out above the newly excavated terrain, were then progressively eroded into various pyramidal forms, then mounds, as electric arcs continued to erode the sharp edges. And finally, the remaining mounds were etched away. Just as industrial applications of electric discharge machining can erode high points to produce a flat surface. All that is left of the earlier margin plains are the few scattered remnants of sculpted mesas and bluffs, disappearing altogether in the flat depression farther to the north. This transitional process can be observed across great distances on Mars with a consistent pattern. Highly cratered, elevated plains to the south, giving way to isolated blocks, then mounds, then the smooth lower terrain that characterizes so much of the northern hemisphere. In early 2004, the Mars rover Opportunity returned images that alone could alter our ideas about the recent history of the solar system. The rover had landed in a crater, and scattered around the walls of the crater were a multitude of BB-sized spherules. Their blue-gray color set them apart from the reddish hue of the iron-rich Martian soil. Thus the informal name given them, blueberries. As Opportunity rolled across the Martian landscape, it found a profusion of the little spheres that apparently occupy the Martian surface by the trillions. But how were they formed? Not long after the discovery of the Martian blueberries, Dr. Ransom set up an experiment to test the effects of electric arcs on different materials. He obtained a quantity of hematite, roughly comparable to the Martian soil, and blasted it with an electric arc. The results were quite spectacular. Embedded in the soil were perfect counterparts of the Martian blueberries. From what is now known about the Martian surface, it's clear that if the planet was engulfed in electric discharge, the spherules are a predictable effect. Ransom's experiments did not end the investigation either. Cameras of the rover Opportunity captured a flat-floored channel with parallel sides. From both walls of the channel, we observed jagged razorbacks, one more feature with no place in the geologist's lexicon. But Dr. Troy Shenbrot and his colleagues at Rutgers University recently produced this very form, razorbacks, in electrostatic experiments. And the researchers did indeed see a direct connection to the razorbacks recorded by Opportunity. Shortly thereafter, D.Z. Parker also produced razorbacks on the charged surface of a CRT screen. Both the razorbacks and the blueberries point to electrical events, and electrical events are scalable. Formations created on a small scale can also appear on a much larger scale. In fact, our orbiting cameras have found numerous craters with domes or spheres resting within them, looking very much like the spheres and craters of Ransom's blueberry experiment. The pictures seen here of domed craters on Mars are from the Mars Global Surveyor. But in contrast to the rover blueberry images, the domed craters range in size from 100 meters or less to a mile or more in diameter. And the pattern occurs even on a larger scale. In the polar region of Mars, the domed craters are up to many miles wide. It is surely reasonable to ask if the tiny blueberries and the far more massive domed craters were produced by the same electrical force, acting on widely different